is a planar system, then summations of xy is equal to 0, fx is equal to 0, summations of fy is equal to 0. Only this you are showing. And when you are imagining as a vehicle is a point, and by point way you are showing, so in a plane you are showing, so here in only you are showing summations of fx is equal to 0, summations of fy is equal to 0. And if it is a coplanar concurrent force, then only by this way summation fx is equal to 0, summation fy is equal to 0, then you are showing that the system is in equilibrium. If it is the coplanar non-concurrent forces there, so summation fx is equal to 0, summation fy is equal to 0, and moment about any point also is equal to 0, that you are creating. So you have seen, just I am telling you, you write some main points so that you keep in your mind that how you have to present the free body diagram. In the trusses system, you will show that everywhere you have to draw the free body diagram. There I will discuss lots of that one. Here was also what I am telling you, you have done, but refresh it. Something should not miss out. So you write point number 1, that free body diagram, what you have to keep in your mind, that self weight of a particle or a rigid body. If it is not a rigid body, then you are showing by a point. If it is a rigid body, then you are imagining that all the weights is acting on the CG. So self weight of a particle or of a rigid body, irrespective of its position, horizontal or inclined, always acts through its center of gravity and vertically downwards, normal to the horizontal plane. So you can write that self weight of a particle or a rigid body acts through its CG and vertically downward, normal to the horizontal plane. Vertically downward, normal to the horizontal plane. Wait for some time, some sound is coming here. Okay, so we have to some sounds means they are creating the smokes for the coronavirus, so it will create some sound will not come properly, so wait for 2 or 3 minutes, because in this one area they are creating the smokes, so I am going outside for 3 minutes. Okay, please be in line.
आपने सीरियसली बीटेक किया था?
जी सर।
आप कॉलेज रोज जाते थे?
जी सर।
ठीक है, अपने पेपर्स के नाम बताइए।
Normal to the horizontal plane, anywhere. Okay. Second, you write, that will be very useful in when you will solve the problem in the truss. Axial forces in any member axial forces in any member. If in the problem it is written that calculate the axial force, then you have to understand which force is there. Axial force in any member may be universally considered to be tensile. So what is the meaning of the tensile? That both forces are acting in the opposite directions, okay, and it elongates the material. Okay, tensile means you are putting a rod and one force you are applying in the upward direction and one downward direction. If it is horizontally, rod is there, you are applying the force, tensile force means one force axially means along the xx line you are pulling in a left direction and one force you are pulling in the right direction. And if you will increase the limit, then material will get elongated. Is it clear to you?
Yes, sir.
Is it? So in the truss system, we will calculate the tensile and the compressive force. So when that axial force in any member may be universally considered to be tensile, and if the results become negative, the forces will be considered as compressive. That you keep in mind. In the truss, this will be used everywhere. You have to calculate the tensile and compressive force. Third, support reaction always acts normal to the support. Support reaction always acts normal to the support. Means wherever support you are giving, either you are giving by a roller support, means suppose that your vehicle is moving on the wheels. So all the weights of the passenger, including the vehicle, acts on the four wheels. So wheels is supported on the ground. So whatever the weight will act by one wheel on the ground, same will be reacted by the ground in the upward direction. So reaction force, support reaction always acts normal to the support. So support is your ground. So on the ground it will act normal to the direction. And when you are driving the vehicles, you are seeing that when a speed breaker is there, you have to slow your vehicle. If you are not slowing, then what it happens? It gets bumps. Means reactions developed by that one breaker is more than that, so it will get in the upward directions and your vehicle will for a fraction of second in the air and it will just jumps and it will create some disturbance in your vehicle. That's why on the speed breaker, being an engineer, you have to know the all considerations. You have to reduce your vehicle's speeds and slowly you have to overcome the breaker. Then your vehicle will be safe. So support reaction always acts normal to the supports. Next point, this also will be utilized in the truss system. Next point, reaction force generated from a roller support. Roller support means feel that in the vehicle, that in the trains you are seeing that the roller support is there, means metals wheel is there and it is rolling on the track, it is rolling. So reaction force generated from a roller support has only one component and acts vertically normal to the support on which the roller rests. Reaction force generated from a roller support has only one component. Has only one component and acts vertically normal to the support on which the roller rests. जिस ग्राउंड पे रेस्ट कर रहा है, अगर इंक्लाइंड रोलर है तो इंक्लाइंड प्लेन के नॉर्मल पे वो एक्ट करेगा। जैसे देखते हैं कहीं रोलर, जैसे ब्रिज उरिज में थोड़ा सा रोलर का दिया जाता है, ठीक है, गैप छोड़ा जाता है, ठीक है, बहुत से एवरी प्लेसेस यू आर सीइंग दैट द रोलर विल expand when the weight will acts on that one, it will get elongated.
I'm sorry, sir. Can you repeat? Acts vertically normal to the
support on which the roller rests.
support on which the roller rests.
Reaction force generated from a roller support has only one component and acts vertically normal to the support on which the roller rests. This also I will utilize in the truss system. That truss is resting one point is fixed and other point is supported on the roller. So there you have to imagine only one reaction force will be act. Okay. Second, next, fifth point, reaction force generated from a hinge. Reaction force generated from a hinge or pin support has two components. Reaction force generated from a hinge or pin support has two components. One along the plane and the other normal to the plane. Reaction force generated from a hinge or pin support has two components, one along the plane and other normal to the plane on which the hinge rests. On which the hinge rests. Next point. Have you understood? Hinge or pin supports, like your door. Door is the hinge, or pin by pin support. It is supported hinge. So if you will give the force, they will be moving only in the horizontal and vertical directions. If suppose that some disturbance in the hinge will be there, so your door is seeing, you are seeing the door that it is moving also in the vertical direction, horizontal directions, and also if you are applying a force, then moment about the hinge also will get created. So in that three direction you will give the some disturbance. Next point, because this will be utilized in the truss system, that's why I thought that okay, first you understood, otherwise it will become not clear when we will solve the problem. Reaction force generated, next point, reaction force generated from a clamped. Reaction force generated from a clamped or fixed support has three components. Comma, two forces along and normal to the plane. Two forces along and normal to the plane of fixity. Plane of fixity and one bending moment. And the direction of moment we will be calculated seeing
So
the
one bending
clock.
what?
Bending moment. Moment will be created and moment.
And so that was fixity.
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 Plane of fixity. And one bending moment. Means moment will get created and that moment creates the bending. That's why it is called the bending moment. In any system, moment will created, you have created a structures, and by that one you are putting some weight and it is passing, and you have clamps.
Yes,
And when you put the more weight, so and more capacity for that one, if you will create, so it will create a bending. Okay, so that's why it's called the bending moment.
okay, sir.
And
So you
the,
have seen. Tell me.
So the other part is two forces along and normal to the plane of fixed CT.
No, fixity, fixity,
Okay.
means where the plane is clamped, fixed.
Okay, sir. Okay. Got it, sir.
So you have seen that three types of reactions you will get, and that all these will be utilized in the truss system calculation. When roller support is there, means like the train bogies are moving, and that metal roller is there, and that roller wheels is rotating on the moving on the track. So you are seeing that the contact area of the metal roller on the track is very limited. That's why friction is very less, and roller friction is very less. Okay, so what happens, you have to reduce the friction so that the engine can carry the more amount of more bogies to drive the vehicles. So there you are seeing that reaction force on the roller is acting normal to the track of that one. Okay, so you have seen reaction force has only one component, and that component acts vertically to the support on which the roller rests. So when roller support is there, only one reaction vertically upward will be there, and for balancing of that one also downward force will act. When it is hinge or pin supported, two components of forces will be there. When fixed or clamped, suppose that you are putting a nail on the wall for hanging of something, so you are forcing it, and after a time you have seen you have put some weight on that one, that if more weight is there, whatever the means reactions will be generated by the nail, then you will see sometime it will get loosened. So xy, x component, two component of forces will become the more than that one, whatever the that nail has created in that one. After that, when you will see that some looseness will be created in the nail. Why? Because moment has created. Because you have put the more weight, and about the fixed point of the nail, wherever it is, in the direction of the wall. So that creates a moment more than that one, what is its capacity. So it will get looser. So fixed has three components, two forces along and normal to the plane of fixity, and one bending moment. Reaction force for the hinge or pin supports, two components, one along the plane and other normal to the plane. Okay, this you will keep in this on mind. These all three will be used in truss systems. That's why I thought that I will refresh you. You have understood in your class 11, 12th mechanics solving problem, but you have to refresh it.
Sir,
Frictional, next, tell me.
sir, in that hinge force, why will there not be a bending moment in hinge also in hinge case?
In hinge.
Yes, sir. Why will there not be a bending moment in case of hinge also?
Because you have seen the door.
Yes, sir.
In the door you have allowed that plane will rotate it about that one point, hinge point.
Yes, sir.
Hinge means it is rotating about that one point, and clamped or fixed means it is not having any moment, any movement about that one, any point.
Sir, so
Okay.
when we say that we have three components of force in case of clamp, it exists because we are not allowing any movement in case of clamp.
Ha. So suppose that a rod is hinged, a rod is fixed. Okay. So when you have fixed, then virtually you have to show that the three forces is acting along the
Yes,
plane,
sir.
normal to the plane, and also you have to show one moment.
Sir, but you said that moment will exist only when a heavy weight will be applied on suppose a nail. So in every case, a heavy weight may not be applied. So why do we always assume that three components of forces are acting?
Because nail, when you are putting on the wall, it is a fixed support. You do not want any movement on the nail. That is your aim.
Yes,
So
sir.
when it is fixed in the wall, so there three components will be acted. One along the plane, one perpendicular to the plane, and one moment.
Oh, since the
Because you
purpose is only to not allow any movement, so three forces are
not
acting.
allowed to any movement. But if you will put more than that one its capacity, then after some time you will see that the moment, due to moment, some looseness will be created. And if you will fix it, you will put the cement and sand mixture after creating the nail and fully tighten it, then these types of situation will not arise when you
Yes,
are
sir.
fixing it. Okay.
Yes, sir.
But when you are hinging or when you are pinning, then you are allowing the movement, you are allowing the moment, because force will act in another point. Because in that one situation it will be a coplanar non-concurrent forces there. So here forces will be there, but you are allowing the moment to have about that one fixed point. So when you are applying the force on a door, that door is opening and closing, so moment will get created, but the forces is acting on the hinge, you will see along the plane and normal to the plane. Is it clear to you or not?
Yes, sir. Thank you,
So
sir.
that will be utilized in the truss calculations. So keeping this on mind, there you have to analyze how it is there, that roller support, fixed support, hinge support, these types of supports problem will come. So automatically in your mind it should generate that if roller is there, so how much or what is the reaction value. If it is hinge, then how much reaction will be there. If it is fixed, then what we have to create, how much forces will be there. Okay.
Yes, sir.
Next point, one point you write that frictional resistance is shown by half arrow line. Shown by half arrow line, comma, parallel to the plane of motion or impending motion in opposite direction.
So
And
parallel
in the
to the plane.
parallel to the plane of motion or impending motion parallel to the plane of motion or impending motion, comma, in opposite direction. And when you are drawing a free body diagram, suppose that a body is there and forces are acting on that one. Okay, and body is resting on the plane. Okay, so when you are drawing the free body diagram, you have to show the body. Suppose that the on one body friction a rope is tightened to the wall and it is clamped with one object, and that mass is resting on the another mass, and that mass is on the plane, and you are applying the force on the lower mass and it is moving. So you have to show the free body diagram. So you have to, for mass M1 which is tightened with the wall by a rope and pulley arrangement, so you show the mass and remove all the forces that is not resting on the another mass M2. And when you are showing the free body diagram of M1, independently you have to show M1. So draw M1, so the reaction for Mg is acting downward, reaction force of this one is acting upward, Mg, and the reaction of the plane of that one mass, M2, is also acting, that you have to show. Tension of the rope you have to show, applied forces, frictional forces you have to show, and this way you have to show. So when you are showing the mass M1, free body diagram of M1, means it is totally free, means not supported by any systems. How much forces is acting on that one, that you have to show. Means you have to show by the forces system M1 is balanced or dynamically balanced. If it is moving, unbalanced force is there, that you have to show by the forces, Okay, is it clear to you? Is it clear to you? Mohit
Yes,
Kumar
sir.
Sharma?
Yes, sir.
Mohit Kumar Sharma?
Yes, sir.
हाँ, तो अब ट्रस्ट का प्रॉब्लम सॉल्व करेंगे हम लोग अगले क्लास, या थोड़ा बहुत उसमें थ्योरी है वो भी डिस्कस कर लेंगे, तो कोई दिक्कत नहीं। और हम लोग आपका 3 डायमेंशनल कोप्लेनर कनकरेंट फोर्स, इसके बारे में तो डिस्कस हम कर ही चुके हैं पिछले क्लास में, और ट्यूटोरियल में हम इसमें 1-2 क्लास और ले लेंगे तो आपका क्लियर हो जाएगा। तो क्या है, इक्विलिब्रियम ऑफ 2 and 3 डायमेंशनल फोर्सेस एंड इक्विवेलेंट फोर्सेस एंड मोमेंट, यही बचा हुआ फ्री बॉडी डायग्राम के बाद। तो 3 डायमेंशनल में भी आपका क्या है, इक्विलिब्रियम में 2 कोप्लेनर कंकरेंट फोर्स है, कोप्लेनर नॉन कंकरेंट फोर्स है। इफ द कोप्लेनर कंकरेंट इज देयर, one resultant you will get. If coplanar non-concurrent is there, one resultant force and one moment you will get. If you have to balance the system, means system is statically balanced, it means summations of all the forces in x direction and y direction is equal to 0 in equilibrium in 2 dimensional. If the equilibrium in 3 dimensional, then summations of fx is equal to 0, summations of fy is equal to 0, summations of fz is equal to 0, and moment also it will get created in the 3 dimensional. If it in the also 3 dimensional coplanar concurrent, means all the forces are coming somewhere else but meeting into in a plane at a point, all the forces, then this will become a coplanar concurrent. But if coplanar non-concurrent forces is there, then moment will also get created. So for the equilibrium of the 2-dimensional and 3-dimensional system, summations, if it is in the 3-dimensional, summations fx is equal to 0, summations fy is equal to 0, summations fz is equal to 0, moment about any point is equal to 0. So by this way you will get the equivalent force and equivalent moment. If you will calculate the equivalent force and equivalent moment, if some value is there, and if you will to balance the system in the opposite directions, and whatever the magnitude of the resultant force is there, you apply the in the opposite direction, whatever the resultant is there, then system will be gets balanced. If the moment is in the clockwise direction, you have received calculated. In the opposite direction you will apply, then the system will get balanced. So whatever the resultant you have got, you apply in the opposite direction of the getting the result, then your system will get balanced. So this is the related and problem related to that one I will discuss in your tutorials. So additions,
non-planar non-concurrent forces are responsible for moment of force, or planar non-concurrent forces are
tell me what you are telling.
Sir, I'm asking, what did you just say was the reason for the creation of moment of force? Was it planar non-concurrent forces or non-planar non-concurrent forces?
No, there are the three systems. First is the system of